This program is to do with recording sound in wave format. It starts off with the usual data sections, but let's see if it compiles. Yep, 4 passes, 4,608 bytes. Does it run? Yeah, looks like it. Exit, program, sounds, make any key to make sounds. Okay. Seems to have worked. Give it a moment. It's thinking. He's thinking about it. Now he's brought up saving sound as file. So we save a sound as file. We won't bother. We get an error saying it didn't work. Okay. It does save a sound. It does save a sound file. And program. Let's have a look at it. It's the usual handles for the memory that we're going to allocate, the menus, device context for the text, window handle, the text for the menu, the various structures, message structure, window class, open file name. Then you've got your message boxes, an error, saved, more actual handles, the filters for saving, the various bits and pieces for sample rates, calculated frequency, loudness, pulse, hertz frequency, divider, loudness, all that sort of stuff. Just set up all the variables. Again, loudness 100, the key, angle, output, move up or move down. Then you've got the code. Start off with a subroutine playing, call RIFF, which fills out the sound structure, invoke play sound, wave out set volume maximum, pointing one into EDX, which is pointing one is the sound data, and then you play the sound using pointing to the first datas. Keyboard, if the window message a character, jump to the keyboard, get a key, sound, pointing, get the first bit of data, first byte of data into EBX. If it's a 0, then return. If it isn't, go to S1, which is here. So we call RIFF to fill out the RIFF structure. We call frequency proportion, then we invoke text out, the text which is that A, B, C, D, E that we saw. Then we initialize the floating point. We free up a few floating point registers for the stack. We get the pointing to the sound data. We add 30 to it to jump to somewhere in the structure. Floating point load pi. We store it in a variable called pi. Then we add pi to pi, and we get 2 pi, 3.14, so that'll be 6.28 point to the data again, call erase, go to random, call sound, call playing, return. Pretty standard, easy to follow. Random, use the get tick count for the random. It's all various stuffs, calculating the frequency rate and the with the frequency. And then erase the EBX, which is the pointing, the structure, the sound data. Flags, check angle again, 2 pi, because we need a sine wave, don't we? Add sound, again it's, you know, load 0, store it in the pulse, load an integer rate, divide it by divider, store it in gradual, so the slope of the sine wave, get the hertz, multiply it by the proportions number, store it in calculated frequency, load the pulse, add the gradual increment, store the pulse, get your sine of the pulse, store that in the loudness, load your angle, add your calculated frequency and store it in back in angle, get the sine of the angle, multiply it by loudness and loudness 2, store the integer as an output, get the integer, add it, and to the sound data, blah blah blah, it's just the same old stuff. Calculating the loudness, so it varies in loudness. Then you've got your frequency proportion here. Again, it's floating point, so pointing one is the data, the sound data into AES. Load an integer from +18 in the sound structure, store that in the samples per second variable, load pi, add pi to itself, so that's 2 pi, divide that by the samples per second and store that in the proportions number. So that's that. Then you've got the RIFF. This is the actual structure for the sound, Wav Sound files. So you get the pointing one is the data, you've got the number of data points, 32,000. You've got to put RIFF in there to let it know that it's a RIFF file, and then you've got the wave file, and you've got various other things which are all explained if you look up on Google the RIFF Wave file, whether or not it's floating point or integer. And that's it for that. Then you start in the real code, the windows, which we've done, you know, 4 or 5 times now. It should know this backwards. Get module handle, store it, load your cursor, store it, define your Windows procedure, your colour of your window, your class, your menu and your class name, register the class, set up your menus, set up your sub menus. Pretty straightforward.